Hi guys, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for spending time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. This is our channel name, Mathematical Side Trips. I am Napoleon A. Gaking Jr., a math teacher. In this video, discussion will focus on construction of simplification expressions involving irrational numbers, where construction starts with the answer. First, we'll take up multiplication and division of radical expressions. Mathematics is an exciting subject to many students. Unfortunately, others find it too difficult, useless, and even boring. Teachers have to do extra effort to arouse students' interest and to make the subject a little more attractive, exciting, and useful. So it pays to give students every once in a while tests that somehow break the routine or monotony. It is hoped that the following sample examination on multiplication and division on radicals achieve even a bit of these intentions. So here we have three multiplication problems of multiplication of irrational numbers. And we have two problems involving a combination of multiplication and division of irrational numbers. As before, these exercises have been constructed starting with the answers, which are in this case 1, 2, 3, 4, and 5 in that order. This same as the problem number. What I mean is, the answer to number 1 is 1. The answer to problem number 2 is 2, and so on. The answer to number 5 is 5. Here is a construction guide. Suppose the answer is a composite number n. So number 1, write n equals the product of its factors, pq. 2, express its factor as a difference of two other numbers, one of which must be a perfect square. So here we have, for p, we have a squared minus b, and for q, we have x minus y squared. Step number 3, we write its difference using the formula for the difference of squares, treating the non-square number as the square of its square root. So we have that step. For division exercises, write the answer as a quotient of two numbers and follow the steps given above separately for the numerator and denominator. The following is a quick reconstruction of exercise number 3. So we write 3 as 3 times 1, and then rewrite 3 as 9 minus 6, and 1 as 5 minus 4. So one of them is a perfect square. And then use the formula for the difference of squares. So we have 9 minus 6 becomes 3 minus square root of 6 times 3 plus square root of 6, and 5 minus 4 becomes square root of 5 minus 2 times square root of 5 plus 2. Step number 4, hide the presence of conjugate irrational numbers by multiplying two of them, one coming from P and the other from Q. For example, n equals a squared minus b times x minus y squared. So which is now a simplification problem. Simplification problems involving cube roots. Just like in previous constructions, we first construct an identity. Consider the expression x. Then we write it as 4x plus 1 over 3 minus x plus 1 over 3. Of course, this is just one way of rewriting x as the difference of two other expressions involving x. And then we multiply the first one, 4x plus 1 over 3 by x squared plus 2 over x squared minus plus 2. And the second, x plus 1 over 3 by x squared minus 3 over x squared minus 3. Then performing the indicated operation, multiplication in the numerator and multiplication in the denominator. So we have these two expressions. The first one is, the numerator of the first one is a cubic polynomial. Both numerators are cubic polynomials and both denominators are quadratic polynomials. Okay, now letting x equals the cube root of 5, we get the identity x equals the cube of the cube root of 5 plus square of the cube root of 5 plus 8 times the cube root of 5 plus 2 over 3 times the square of the cube root of 5 plus 6 for the first rational expression of x being replaced, where x is being replaced with the cube root of 5 and so on. So simplifying this, we have the cube root of 5 equals 22 plus the cube root of 25 plus 8 times the cube root of 5 over 3 times the cube root of 25 plus 6 for the first rational expression, and 2 plus the cube root of 25 minus 3 times the cube root of 5 over 3 times the cube root of 25 minus 9 for the second. So we now have a simplification problem involving cube root, where the right hand side expression, when simplified, is equal to the left hand side, which is actually the cube root of 5. If we use another value for x, say the cube root of 7, then we obtain the following expression. So again, when you simplify the right hand side, it should simplify to the number on the left side, which is the cube root of 7. Clearly, the two right-hand side expressions are not typical simplification exercises that a teacher would give a typical algebra class. The resulting expressions would be even more intimidating when construction starts with something more complicated than a scalar multiple of x, or by increasing the degree of h of x in the fraction h of x over h of x, which is just 1. Obviously, simplification exercises involving fourth and fifth roots can also be similarly constructed. That is all for now. We hope that you have learned something new, interesting, or useful. The next video is about other forms of irrational numbers. God bless.